Integration by parts then. We know the product rule for two products u times v is u dv plus v du dx. Here's the formula here, the product rule formula. So we could rearrange this as u dv dx then equals, and it's d by dx of uv here, and move this over to be minus v du dx, isn't it? So we get this line here. And then if we integrate all the way through, the integral of this side with respect to dx is equal to the integral of this side with respect to dx, isn't it? When you integrate a derivative, you just get back to where you started. So that's why you can write uv here. And then if you integrate this, the minus can come through and you get integral v du dx. And that's the formula for integration by parts. It's for integrating products of this form, u times the v. And here's our first example. So it's best explained by examples. You have to choose, when you're integrating products, each constituent part, usually you want to be able to integrate or differentiate. And that's the rule. So you just make a choice. So let's let that be u and let that be dv dx. We usually don't write dv dx. We abbreviate that to b and dv. So let's have a go at it then and put down the answer. So the answer should be, if we make this choice. Now if we get a worse integral here, or we can't work out this right hand side, or this is a worse integral, then we've made the wrong choice. At the moment, because we haven't got much experience, we've got a 50-50 chance of making the right choice. If we end up with something worse though, we can swap it around and see if it makes it any better. So it's trial and error. So I've made that choice here, of that part of the product and that. So it'd be u, which is x, v. Now integrate to get from dv dx, integral of e to the x then is e to the x, minus the integral of v, so the integral of this thing here is e to the x, times du, and the derivative of u is 1, isn't it? Dx. So I've written it all down by hand. So x e to the x is fine. This is the integral of e to the x, which is just e to the x, plus k, and there's our answer. So we did make the right choice, and it made it easier. Do you notice also that we did it all in our heads, because we let u equal x and dv dx equal e to the x, and then we wrote down the constituent parts. So du dx we needed, didn't we? Yeah, we needed du dx, and that was 1, and we worked that out in our head. Put it here, and here we needed to integrate dv dx to get back to v. The integral of e to the x is e to the x. So for the purposes of the formula, we don't put in an arbitrary constant, we just do the integral function. And we got v, so we put that part in there. So I hope you can see all this work here we did in our heads when we did the problem. You can always write it out long-windedly if you're a little unsure. But I'm going to proceed on this basis. So let's do the next example now. Integral, and it's a definite integral, naught between pi over 4 of 3x plus 1 times by sine 2x. Really awkward problem. So let's do it again then. U dv dx. So the answer then, if we make this choice for the product, it would be u, which is 3x plus 1, times v. Now the integral of sine x, if you look it up, sine 2x is minus cosine 2x over the 2. That's uv minus the integral of v du. So v would be this thing here, which you've just done. It's a minus cosine 2x over 2 times du dx. And differentiating this, this goes to nothing, this goes to 3. So it's times 3 dx. So let's tidy it up then. It's minus 3x plus 1 over 2 cosine 2x plus the integral of 3 over 2, I'll bring that out over here, 3 over 2 lots of cosine 2x dx. Now the point is, the problem is it's a definite integral, isn't it? So in this case, because it's a definite integral, we've got our bounds to work it out from and to. So that's 0 to pi over 4, and this is from 0 to pi over 4. So it's a definite integral. So this is equal to then, it'll be top value, take away bottom value on the first thing here, plus 3 over 2 lots of this integral. Integral of cos is sine over the a, which is 2, and that's also between 0 and pi over 4. This pi over 4, sorry. That's better. Okay, and that was between 0 and pi over 4. Okay, so now we need to work this out then. This 3 over 2 is outside here really, but it doesn't make any difference to put it there, and that's actually 3 over 4. So top value, put pi over 4 in here. I'm just going to do it now. Minus 3 pi over 4 plus 1 over 2. Cos of 2 lots of pi over 4 is cos 90, which is 0. Cos 90 is 0, so the whole thing's 0 then. So the top, that first thing was 0. And then put 0 in here, you get 1. Cos 0 is 1. And you'll get minus a half times 1. So top value, take away bottom value. Oh no, that was still top value. Sorry. Top value. Oh. Yeah, it was 0. Okay, take away bottom value. I've put 0 in now. Cos 0 is 1. And we get minus a half, don't we? Times 1. Yeah? Minus 1 over 2, because x is 0. Cos 0 is 1. Okay, so what do we get then? We get plus a half. Plus, and then we got this second box to work out, which I haven't worked out yet. Top value minus bottom value. This is 3/4. Sine 2 pi over 4 is pi over 2. Sine pi over 2 is 90. Sine 90 is 1. And then bottom value sine 0 is 0. So that will be 0. So we've got a half plus 3/4. 2/4 plus 3/4 is 5/4. Or 1 1/4. Hard example that. Next example. It's another definite integral. It was tedious rather than hard, but it was quite hard actually. 0 to pi over 3, and this is another hard one. X squared cosine 3x. Now this is difficult as well, because it illustrates another further subtlety. Because even though I said does the integral when we're doing parts, the point is when we do parts, do we get an easier problem? We could always solve the problems we've done in one straight step, but sometimes we have to go down one step and then down another step. So the point is, does the parts make it easier? And then if it makes it easier, we'll then do it again to get down to ground level, and then we can tie it all up. So here we got 2 here, so it's like going down 2 steps instead of just 1 from as before. You see with the other ones, that was an X, so that was going down 1 step. And this one, the first one was going down 1 step. But I got a feeling when you look at this that we'll have to go down 2 steps. So let's try it then and work our way through it. U dv. Okay, so it's going to be equal to u times v. The integral of cos 3x is 1/3 sine 3x. So there's uv minus the integral of u x squared. Sorry, I'll get it right in a minute. U is x squared v minus the integral of v du, wasn't it? So v is 1/3 sine 3x times du, which is 2x. And this was between 0 and pi over 3. Okay, so that's equal to x squared over 3 sine 3x between 0 and pi over 3 minus 1/3 of I've written 2 here. Du is 2x, so that should have been an x. 2x dx. Again, I'll get it right in a minute. So it's minus 2/3, then the 2 can come out. 2/3, that can come out as a linear factor. The integral is between 0 and pi over 3 of x sine 3x dx. So here's our answer then in the first instance. Notice we started with x squared cos 3x and we've ended up with this thing which we can work out, minus 2/3 of this integral. So if we label this I, this integral in form is just an x sine 3x, that was an x squared. So this is easier, so we have made a step in the right direction. So let's label that j then and do a sub-problem. So draw a line across the page. Let's do our sub-problem then. J equals right, so again we do the same thing, u dv dx. If we did the reverse, we'd step backwards and get nothing. So we need to do the same again. So it's equal to u times v, x times the integral of sine 3x is minus cosine 3x over 3. There's uv minus the integral of v, which is minus cos 3x over 3, that's v, times du, and now we're down to one lot of, aren't we, dx. So there's our formula, that becomes a plus, so we've got minus x cosine 3x over 3 between 0 and pi over 3 plus the integral, we can take the 3 outside, the third cosine 3x dx, that'd be between 0 and pi over 3. Okay, good. So what do we get here? 0 pi over 3. This would equal, put top value in, cos of 90 here, cos of pi, wouldn't it? Would be minus 1. So it's minus, top value would be minus pi over 9, put that in there, times minus 1, because cos pi is minus 1, minus, that's the top value, the bottom value, minus, 0, because x is 0. And this would be plus 1/3, integral of cos is sine 3x over 3, between pi over 3 and 0. And when you put the top value in, you get sine pi, which is 0, and the bottom value gets sine 0, which is 0. Both of them are 0. So we just end up with pi over 9, don't we? So that's j. So we can draw a line across the page now, and we can proceed with our main problem. That was our sub-problem for j, which we've worked out to be pi over 9. So if we go back up now then, we've got pi over 9 for j. Now I'm normally write on a fresh line, but here I'm just going to scratch it now because I now know j is that. So now I'm going to get rid of this section and proceed with the main problem, because that was a sub-problem. J is equal to pi over 9. So j equals pi over 9. So I then, so that's the end of our sub-problem. Top value, pi over 3. This is 0 both times around. So we get minus 2/3 times j, which is pi over 9, which is minus 2 pi over 27. The reason that was 0 was because when you put pi over 3 in here, you get sine pi, which is 0. When you put the bottom value, you get sine 0, which is also 0. So we end up with minus 2 pi over 27. Now the next problem I'll do in the first examples.